Good morning, students. Today, myself, Alok Kumar Mishra, is going to discuss about the topic resistance, resistivity, and their differences. And some numericals will be also discussed in this part. So, what do you mean by resistance? In previous classes, that was discussed. But when we discuss resistivity, we need to know resistance. So, both resistance and resistivity are fundamental property of a conductor, matter, and both opposes the flow of current passing through the conductor. Okay? So we need to know about the resistance. So I am going to draw the difference, draw the column methods in column. So first point, we will write about resistance denoted by R, okay, and resistivity, it is denoted by rho, omega, you can say that. So first point is that, what is the first point? It is the fundamental property. It is defined as fundamental property of a conductor due to which it opposes the flow of current through the conductor. It's very clear, students. No problem about that. And resistivity is also fundamental property. It is defined as the resistance of a conductor having length unit meter. Unit meter means unit length, or unit length or 1 meter. We have to write here 1 meter or unit length and unit area of cross section. Unit area of cross section. Okay, 1 meter square. So it is defined in the form of resistance. It is defined in the form of resistance. So it is also fundamental property. It is also a fundamental property. Clear? of conductor, of material, of conductor. Now, the second point we will discuss. I am going to rub this. Now, the second point is R is equal to ratio V and I by Ohm's law. By Ohm's law. Okay? What is the formula of this? But here R is equal to, in term of R. So rho is equal to R. So how can we find? First of all, just try to see here. R is equal to rho into A by A. So from this formula, rho is equal to R into A divided by A. This is the formula of the resistivity. Understands? Third, the SI unit. The SI unit of resistivity, resistance is ohm. In the name of scientist, great scientist Ohm, and symbol is that. And here the SI unit of resistivity, you can also say that a specific resistance. So now SI unit, what is SI unit of rho? Here I have written the symbol, and rho is equal to ohm. SI unit of resistance ohm, meter square divided by meter. So ohm meter. Fourth point, very important. What are the factors on which resistance of conductor depends? So R, that means resistance of a conductor depends on point 1, length in second. You have to write A here because I have written 1, 2, 3. B, area of cross section of the resistance. A, material from which it is made up. Material of the conductor. And fourth point, D point, temperature. What is the temperature of that time? It depends. Understands this? So, and in this here, fourth point, it depends only on the material of the body from which the conductor is made up of. So nature of the conductor on the material of the conductor and temperature. These 2 points very important. This 2 point is very important. This is the differences. This is the difference between resistance and resistivity. Okay, a specific resistance. Understand? So the question is that I am going to solve one more questions regarding that. Okay. So supposing a conductor is, the length of conductor is double. What will be the value of the new resistance, the new conductor? Questions 1, if the length of a conductor is doubled, then what will be the new value of resistance? So this is simplest questions regarding the resistance. So supposing here this is the length PQ whose resistance is R, length is A and area is A. This is just becomes double without stretching. Remember students, without stretching. So this PQ becomes P dash Q dash and length becomes 2A, double the length. What will be the new resistance? Supposing new resistance is R. Area of the conductor remains same because it is not stretched, only it becomes doubled. So length is and specific resistance is same because material is same. And area is here. So here, as we know that R is equal to rho into L by A. This is equation 1. And in second case, R dash is equal to rho into material is same but length L dash and A dash. So A dash is same here. Now put the value. Rho into L dash is equal to 2n. A dash is same. Now this is 2 into rho into A upon A. So what we see that R dash new resistance is equal to 2 times the old resistance. So 2R. The value is 2R ohm. So this is the new resistance which is just becomes double. But question is that again, if triple, you have to put 3 times. But if the question comes that it is stretched in such a way that its length becomes twice, then the question becomes different. Okay, so now we will discuss that. So if the resistance is, if supposing length is second question, length is A, this is the length of the wire, okay, PQ, and it is stretched like that, elongated, stretched and becomes twice. Second, the length is twice and the area becomes, you just see that thickness of this wire becomes thinner and thinner. So P, Q, so area is A by 2. What will be the new resistance? The question becomes different here. So I am just going to solve. You try to see here. What will be the value of that? What will be the value of that? Here again same things. R is, supposing the resistance of this length is R and specific resistance is rho. So R is rho into L upon A. Same. But here the new resistance R dash is equal to L dash by A dash. Put the value because wire becomes thinner, it is elongated, stretched, then area is thinner. Okay, so right here rho, length becomes 2 times the original, but area becomes half of that. So A by 2 here. So now R dash is equal to rho into 2 into 2. This 2 goes upon and L by V. So 2 into 2, 4 into rho into L upon A. So R dash new resistance 4 times the old resistance. This is clear, students? So this is the some numericals based on resistance and resistivity. This will help you to solve various numericals related to the resistance and resistivity. Resistance, remember once again, resistance and resistivity both are fundamental property of conductor. Resistance depends length, area of cross section, material and temperature. But remember, resistivity, a specific resistance does not depend on length and area. It only depends on material of the body. If the material is changed, resistivity will be changed. So material of the body, conductor and its temperature. Remember, these are the main differences. Okay, I hope that you will get, and this will help to increase the knowledge in the part of the resistance and resistivity. Thank you.